Yeah, so we start with exoskeletons, and when we say we're going to build Iron Man, every single one of you forms a picture in your head of what we're going to build, and I can guarantee you it's all wrong, right? Every single one of you, that's not what we're making. We make something that looks completely different. Our exoskeletons are made entirely out of fabric. They're lightweight, they use air to provide structure. Essentially, we can provide order of magnitude cost and weight reductions compared to conventional technologies. So I speak to this from a very unique place. My background, I was one of the lead inventors of Exo at Exobionics. So this is probably the most commercially successful exoskeleton in the world today. It's used for gait rehabilitation, things like that. These traditional devices are awesome at certain things. Primarily, these devices have started to make inroads in inpatient gait rehabilitation. They really do good things. For the first 2 years of the device, it was me and one other person were the only two who could actually run the device. So I was right there every single time when somebody got in, stood up, walked, right? The emotional high of having somebody who hasn't walked in 25 years and helping them stand up and take their first steps, right? The tears, the hugs, the family, all that kind of stuff. It's great. It's really hard to explain. The problem is with these devices, that emotional high is paired with the low of after an hour, we sit them back down, we put them in their wheelchair, and they roll out the door like nothing ever happened. And that's what every single session worked like. So that's what we're intending to fix. We want to make exoskeletons accessible. So see, the problem with these technologies is they're heavy and expensive. And it's not because we just decided to make them heavy and expensive, which surprisingly is a thought for a lot of people. It's a fundamental limitation. They're always going to be heavy and expensive, and that's the only way that we're going to be able to move forward with these devices. So what we need is a fundamental jump, a break in the way we evaluate exoskeletons, the way we're planning on making these devices. That's what we need for the future. So what we're making is, and you can see this here, and you'll see more in our demo booth, we're making this new type of device. It's all fabric. It kind of uses geometrically constrained shapes in order to transmit these loads. They're high-strength nylon weaves. And then inside them, we use a slight amount of air pressure in order to provide quite a bit of structure and stiffness, both for actuation and the passive structure as well. You can see here at 20 psi, he's able to fight with that, and it provides a lot of rigidity for something that weighs next to nothing. From there, you can kill the pressure, and it goes back to 2 pieces of fabric. That's essentially what you're dealing with. Now, we took this technology and we adapted it into kind of early proof of concepts, so people could begin to understand what are we talking about. This is an elbow flexion exoskeleton. Essentially, it's providing at 20 psi, it provides about a quarter of the peak torque of a normal human elbow. What's great about this, and just you step back from it, those sound like fun numbers, but this is 1 pound in device, and it's $20 in materials. In my previous life, I built an upper extremity exoskeleton. We were all really proud of it. Same peak lifting capabilities. It was a 15-pound device, and it cost $20,000 to build. There is fundamentally no comparison with conventional technology. We're not talking about we're shifting. It's a completely new ballgame. So why does it matter? How does this mean something? We have arms that we connect to the wall right now for demonstration. What does it mean for you, right? So I'll look at existing solutions. There's 2 things that make up the weight of existing devices. This plot is basically going to show you weight of devices, and I'm using weight to kind of as a strong parallel to performance. As you get lighter, things get easier, you can do more, things like that. So this is the existing device. This is actually Exo. It's a 55-pound machine. It's about 10 pounds of batteries, 45 pounds of structure and actuation, things like that. And people always say, when you say, we want to build Iron Man, we're making exoskeletons, they say, oh, you need the arc reactor, right? You need Iron Man's little chest thing. I'd love it. I really would. If one of you guys is making it or funding somebody who's doing it, I'd take it. I'm all for it. Problem is, it doesn't actually solve our problem, right? If I had that device, and you gave me the arc reactor, magic batteries, it doesn't make my device really all that much better. So what we're proposing is we're proposing a solution that takes the system and fundamentally changes it. You can think, $40 billion, 30 years of work, making perfect batteries with demonstrated technologies today, we can provide 4 times the benefit that those do to exoskeletons. So that's where we're going. So when we think of the addressable markets, so a lot of people will step up and they'll say, all right, so are you making a niche device, right? Are you doing pediatric rehabilitation? Or are you doing inpatient rehab? I think that's the wrong way to look at what we're talking about. What we're proposing is we're proposing a technology that fundamentally changes the way you're going to step in exoskeletons. And so every place exoskeletons have an opportunity, we think these apply. So I look at it as a breadth of capabilities. At the one end, you have peak capabilities, which is the military. We're trying to make these people superhuman. do things well beyond what any of us are expecting doing. Moving into industrial, we're talking about maybe not as continuous, but still kind of high load, high capability actions. You move down into consumer applications, you can think elderly assist, you can think hiking, recreational, training, things like that. So this is what we can all do, but we just want to do it better, do it longer. And then all the way down to the other side on the impaired end of the scale, and we're actually improving people's lives, improving capabilities. So we think that we apply to all these spaces. You look at conventional devices, they've only made inroads into inpatient gait rehabilitation. Like I say, that's awesome, but the problem is this is the dream. The dream is far bigger. And if you look at these conventional technologies, they're either cost limited or weight limited or agility limited in every single one of those areas. And so I can make strong arguments. We can talk about any of these individual that resonate with you guys of why our technology is the one technology in the world that can apply to these other areas. There are unique benefits in one of these two reasons why traditional devices can't migrate there. So what are we doing about it, right? What does our path look like? So right now, as Saul said, we're on contract to build Iron Man. And so what that looks like for us is we're going to spend the next year moving from our initial proof of concepts into integrated machines. We're going to develop the components, the infrastructure, the basic science that provides us this capability to make this jump. And so that's what we're doing with this project over the next year. From there, we're going to take those as tools, and we're going to integrate into initial products, essentially. And so what we're looking at is areas such as industrial assistance, right? $15 billion a year spent on workman's comp injuries for overexertion due to lifting. That's a crazy number that we accept by just paying out the bill. So lift safety for people in industrial environments. Elderly sit-to-stand transitions. The elderly population is growing drastically, and sit-to-stand transitions or stairs are the number one scenario in which people fall and have injuries that lead to significant care costs. So what does the vision for us look like? I actually honestly look at exoskeletons, and I look at a future where exoskeletons are pervasive. They're everywhere in our lives. They're embedded into what we do. They form the standard of care models for the way that we do rehabilitation. They seamlessly blend into the way people go into their world and have assistance to continue to do things better. It's how we play longer, play harder. It's in our jobs. It's in the military to help them continue to do more. And I honestly feel that our technology gives us a unique ability to do that, to actually execute on this dream and for the first time make exoskeletons accessible. Thank you.